So what we're going to do is we're going to talk about the quadratic formula. Now, basically, we got a way to find roots of a quadratic equation for all possible parabolas based on the standard form of the equation, which is ax squared plus bx plus c. Now remember that comes from the equation y is equal to ax squared plus bx plus c, and specifically when we're trying to find the roots, which are also known as the x-intercepts, which are also known as the solutions depending on the type of problem that you're working with, start by letting y is equal to 0 and then solving. Now, as you can see here, I said the full derivation for this equation is basically on page 293, and I provided a video for you to look at if you wanted to see how it came about. Now, as I said before, we're looking at this basic equation and we're solving for it. And what we're looking for is what x values give us the right side of the ax squared plus bx plus c equaling 0 to be 0. That's all we're looking for. So this is the basic equation that we're using. It's x minus b. X is equal to negative b plus or minus the square root of this thing that I call the discriminant, because the discriminant kind of tells us something about the number of roots. It's very important. It allows us to discern between parabolas that have a vertex below the x-axis, above the x-axis, or on the x-axis. Now we have b squared minus 4a and c, all divided by 2a. This equation is one of the most important equations you'll ever know. It's used in physics. It's used in biology for different things. It's used in business in order to find the minimal points of certain things. Okay? And it also can be used to find the zeros of any arc or arch that we use. Okay? Now, what I'd like you to do is, if you feel interested, go take a look at the derivation. Just speed up the video. It's about 17 minutes. You can listen to my beautiful voice. And basically what we're going to do right now is we're just going to move on to the first example of today. Now just remember that this is one of the most important equations based on this equation, ax squared plus bx plus c. You need to memorize it. Okay? So, for example, one of our lesson for today, we're talking about rational roots. Rational roots are pretty nice in the sense that we can, when I talk about rational roots in this sense, we're talking about anything that does not have a square root sign on it as our final solution. You will see that later on in today's lesson. So normally when we took a look at this equation, solve a quadratic equation, basically what we would do is we would go about doing it and factoring. Now, solving means solving or finding the roots or finding the x-intercepts. So in this case, when we would do our old way of doing this, we would just go and factor, and we get something like this. We find our multiple of -6 but adds to 1, and we do our, in this case I'm using Berry method to find our solutions. And so we have x equals 2 and x equals 1/3. Now, just like I showed you before in one of our lessons, I actually showed you that when we did these problems, we could link it back to what we had before, because some of you guys didn't believe it. Now, on your sheet, I told you at the beginning of class that I wanted you to go and follow the QR code on your sheet, and I wanted you to find out what b squared minus 4ac, the determinant, basically told us. Now, you should have something like this. So if you take a look, b squared minus 4ac is greater than 0. In English, we mean that there are two roots. The x-intercepts, the number of x-intercepts is 2, and the number of solutions is 2. Now, when we draw the picture, you're going to see that you have a parabola opening up that has a vertex below the x-axis. And if a parabola is opening down, the vertex is above the x-axis and forces us to have two solutions. Now, for something where we have b squared minus 4ac is equal to 0, the English is the number of roots is 1, the number of x-intercepts is 1, or the solutions is equal to 1. You choose. Each of those are synonyms of one another. Now, the pictures are, if you think about it, you end up with a parabola that just touches the x-axis at its vertex, either opening up or down. An example of that would have been x minus 3 quantity squared. We've seen that before in chapter 3 of this unit when we were graphing these things. Now, the next thing, for b squared minus 4ac less than 0, the English is there are no roots, there are no x-intercepts, or there is no solution. It depends on the problem that is given to you. Now, what I want you to do is I want you to take a look at this new way that we solve using the quadratic formula. Now remember, the quadratic formula allows us to solve or find the x-intercepts of our parabolas. So this is how we're going to do it. So the first thing that we're going to do is we're going to start by using b squared minus 4ac, and we calculate what the result is. Now you'll notice how I wrote the basic equation. 0 is equal to 3x squared plus 5x plus minus 2. And I basically related it to that old equation 0 is equal to ax squared plus bx plus c. So we know what our a value, our b value, and our c value is. We're going to substitute that into our equation. So we go b squared minus 4ac. Then we substitute 5 squared minus 4 times 3 times negative 2. And then we solve. And when we get our answer, you'll notice I end up with b squared minus 4ac is 49. So that means, based on our chart over here, if b squared minus 4ac is greater than 0, then I could say there are 2 roots, 2 solutions, or 2 x-intercepts. Now, here is the crux of our work for today. When we've done this stuff here, part 1 is pretty easy. We can tell based on this chart what's going to happen. But now what we're going to do is we're going to substitute this into our basic equation. So this is our basic equation. So we use the quadratic equation in conjunction with the determinant that we used as b squared minus 4ac. Now remember, we calculated all the stuff in this, right? So we're just going to punch in 49 here. And then when we simplify, we end up with negative 5 plus or minus 7 over 6. Now, when you take the square root of 49, it ends up just being 7. And now because of this plus or minus, it allows us to have 2 different possibilities for a solution. One of the solutions is x is equal to negative 5 plus 7 all over 6. And the other one is negative 5 minus 7 all over 6. So when we're doing this, we just need to simplify the equation on the left here. X is equal to negative 5 plus 7 over 6. You end up with 2 over 6, which ends up equaling x is 1 over 3. Holy jeez, look at that. Doesn't that look familiar? Look up top there. X is 1/3 is one of our solutions. Now let's do the same for this right equation here. So now we're going to substitute. We're going to get x is negative 12 over 6 when we simplify, which gives us x is equal to negative 2, which is what we're doing. So when we use the quadratic equation, this is what we get. All right, we're good to go.